So, with the pleasant morning, happy morning. So, days are very soothing days because somewhere rains are coming, breeze is coming. So, we see green everywhere. So, green is life, green is God, green is great. Hmm. So, with this, let us start today's session, or let us continue our P block discussion. So, in the P block, last time in our previous session about nitrogen we studied. Today, we continue our journey with the second member of the same family, that is 15th family. So, second member is phosphorus, or Mallikarjun Kruger said phosphorus. Okay, in the phosphorus, I think we have studied in the beginning about the phosphorus, allotropic forms of phosphorus, all that we studied. So, I am just flashing. So, this is regarding the importance of phosphorus, then allotropic forms of phosphorus, why it is very reactive, that all those angular strain, single unit, so everything explained on the structure ground, on the ignition temperature ground. Okay, so regarding some important physical properties, normal properties, and in the black again alpha and beta depend upon the structure part. So this all we studied. Today we will go to compounds of phosphorus. Two compounds we have to study. One is hydride of phosphorus and the other one is halides of phosphorus. So in the hydride, the most important hydride of phosphorus is pH3, like ammonia NH3, it is pH3. First member nitrogen, hydrogen NH3. Second member with hydrogen pH3. Okay, they show similar properties because they belongs to same group. So today first we study about the pH3, phosphine or phosphine. Then we go to the halides, and in the halides we don't study all the halides, we study only the chlorides. So halides is a very big, bromides are there, chlorides are there. We in brief go through chlorides of phosphorus. In the chlorides there are two types of chlorides, one penta, one tri. Okay, so this is what about the phosphorus. So that we will go to the next group, that is 16th group. Before 16th group, one more small bit is there, that is oxo acids of phosphorus. Okay, right. So we will start hydride of phosphorus. The most important is phosphine. So in one sentence I have given conclusion, in the beginning only conclusion. Actually conclusion will be given at the end, but here today I made in the beginning only conclusion, so that about the phosphine we will understand in the beginning only what is phosphine. So it is a colorless flammable gas that is slightly soluble in water and has a strong fishy odor, used as a pesticide. Or everything comes in this one small water. Statement about the phosphine. Structure is there, okay. So meaning is there and use is there, application. But still, so now we'll analyze, we'll understand what is given in the statement. Okay, right. First, how phosphine is prepared, okay, on a small scale in the laboratory. First and the foremost point is what phosphine is highly reactive. So whenever we are preparing not only phosphine, any phosphorus compounds, phosphorus itself is very reactive. So and its compounds also very reactive. Sometimes they become explosive. So we have to handle with care. Sodium, phosphorus, uranium. So all those elements and their compounds are handled always with lot of care, because of what? Because of their property part. So in here also phosphine is very reactive plus very dangerous also from the health point of view. So therefore, so using a lot of care, so with a lot of precautions. So our precautions and the one who is doing nearby us, everybody's health is very important. Therefore, with a lot of precautions, we have to prepare phosphine. So first method is what? You take calcium phosphide, Ca3P2. Okay, this calcium phosphide we use uh, as an agent for artificial ripening. So in the summer, in the month of March or the April, we get mangoes, raw mangoes, green mangoes, sour mangoes. So those sour mangoes are made in just 1 or 2 days yellowish by spraying this calcium phosphide powder. Okay, so it gives a lot of heat, highly exothermic. So nowadays demand is there in the market, so they will not wait for the weeks together or the one fortnight, so that naturally they will ripen mangoes. But now, so using some synthetic methods, we are going for the artificial ripening of fruits. So, but we have to wash thoroughly whenever we are eating the fruits, because they contain a lot of chemicals on the skin part. So, this calcium phosphate will use to prepare the phosphine. So, either with water or with acid, because calcium phosphate is highly reactive. Therefore, just you add water or the dilute HCl, boil it, so you will get a phosphine gas. But in the laboratory, it is prepared by taking red phosphorus, okay, or white phosphorus. So if you are taking white phosphorus, again highest level of care. And you have to maintain inert atmosphere, because it is highly reactive. It may react to the surroundings or with the atmosphere, or the one who comes in contact with the phosphorus, white phosphorus. Red is okay. It takes little time, but safe. So from the safety point, red is okay. But if you want a very good quick result, white, but maximum care. Okay, so either with white pea or red pea, so phosphine is prepared. Method is same, only thing is it is a precaution matters. Okay, so the phosphine PS3 obtained, so when it comes in contact with air, it immediately burns with this water, some smoke. It highly reactive. It converts into either P2H4 or P2O5, depend upon the what is available in the immediate surroundings. So that's why we get a smoke. So that smoke uh, gives a kind of sound. They are called as the vortex of smoke or the gas of phosphine. So that's why. So it is collected by the downward displacement of water. If you leave like that only, so you will get a vortex of that pH3. So in the form of either P2H4 or P2O5 or some phosphorus smokes together. Otherwise, directly you can collect by the downward displacement of water in the laboratory. Okay. So it contains some impurities because it is highly reactive. So it will not come as a pure. Wherever you have a purity, wherever you have reactivity, so getting impure is very difficult. So we have to go with electrical method, so which is very difficult. Therefore, so in the normal lab method, we prepare it. So there some contaminations are there. So our next work is to go for purification. Hmm? So when it is pure, it is non-inflammable. Okay, but becomes inflammable owing to the presence of P2H4 or P4. It is because of the impurities, it becomes highly inflammable. Okay, so for this, we have to purify by passing this PS3 into what? KOH. First HI, so that PS3 becomes PH4I. How NH3 becomes NH4I. So we have seen many ammonium compounds, ammonium iodide, ammonium chlorides, all those are called as ammonium halides, which are salts, which are ionic, more of ionic. So in the same way, being a second member, so here also PS3 is converted into PH4I, phosphonium iodide, ammonium iodide, in the same way phosphonium iodide. So that is collected because it is easy to store phosphine in the form of phosphonium iodide. Then that phosphonium iodide is taken separately. One more method is there. So that is with KOH. Okay, it is made to react once again separately. So KOH will remove all the impurities except PS3. Okay, so PS3 it comes out separately, leaving behind all the impurities, and that is the pure form of PS3 we collect by the downward displacement of water in the laboratory. So it is to purify. The properties are very interesting properties. As I said, highly reactive. Okay, so colorless and explodes when it comes with the oxidizing agents, because it wants to burn immediately PS3. Okay, so that's why whenever any normal, even normal also OA comes in contact with each other, it burns. Okay, So that's why we have a vortex of smoke in the laboratory. Slightly soluble in the water, but pH 3 in water, so it decomposes in the presence of sunlight. That is H nu. So photochemical reaction. So giving red P and H2. So this method we use. This is a property of pH 3, but this method becomes, this property becomes what? Preparation for the red phosphorus. Okay, right. So with D block salts, it reacts and converts into water respective phosphides. So two examples are given. You take any what D block salts, chlorides, sulfates, bromides, carbonates of copper, nickel, mercury, cobalt. So all those, if you want corresponding phosphides, you convert it. Okay, but these phosphides are not so much reactive like our sodium phosphide or the calcium phosphide, what we use for artificial ripening. So they you can handle easily, but those are very reactive. So those phosphides, so those to be handled with a lot of care. Here, if you don't take care also, even without using apron or the gloves, we can handle easily. Okay, so these are D block phosphides. S block phosphides are reactive. P block next, D block last, and F block rarely we find. So regarding phosphorus with D block, sorry, F block. And like ammonia, ammonia is a what NH3 with a lone pair of electron. So you can see extreme right top the structure of phosphine where I have shown a lone pair of electron. So because of this, it is basic in nature. So same property because same members of the same family. So giving what phosphine and the hydrogen bromide. So when the phosphine reacts with the hydrogen halide, HBr, HCl, HI, so corresponding phosphonium halides are formed, similar to ammonium halides. So what we have studied in the ammonium halides, in the same way, in the same pattern, in the same fashion. So here also phosphonium halides are formed. Okay, one sample I have shown of phosphine with hydrogen bromide gives phosphonium bromide. Now list is very big regarding the application level or the utility or the uses of phosphine, but one or two important we have to concentrate. So one is what? One is it is used as a dopant. Dopant is what? Dopant is to enhance the electrical conductivity. So in the physics we learn under the semiconductor chapter, so where the mobility of electron, 15th group, So uh, what is the configuration of the nitrogen? It is 1s2, 2s2, 2p3. So three unpaired electrons are there in the three different orbitals. So these three unpaired are very much useful. So they are doped, means what? Mixed. Okay, mixed with other categories in the making what semiconductors. So let it be diode, triode, or any cell. So whether it is a, motherboard of a laptop or a desktop, anything, wherever you are using the semiconductor technology. So there, to enhance the electrical conductivity, so they are mixing small amount of this phosphine or the phosphorus also. So that is called a doping technique. Okay. So we have heard doping only in the sports field, not in the chemistry field. So doping is a kind of increasing the sudden energy. So athletes, so when they go for the 100-meter sprint to create the world record, so actually it is officially not allowed. It is banned. So, but nowadays different methods are there to check whether he has taken drug or not. So certain medicines or drugs are taken just a few minutes before the event. It gives a lot of stamina and lots of energy, and he will run so speed and he can go for the world record. All those you might have heard on TV, newspaper, but they are arrested afterwards and medal is taken back. So we have to win the medal in a fair way, not in the unfair means. Okay. So that doping is different. There also it is enhancing only. There also it is improving only, but there we improve our performance. So here it is improving the semiconductor technology. Okay, so doping is to enhance what we expect. Okay, so normally semiconductors are giving electrical conductivity, but to enhance in a better way, so we are going for doping. So that we learn group 15th, group 16th, group 17th members are doped so that electrons will move in the circuit, and that is the reason for conductivity of what semiconductors devices. Okay, so that is what as a dopant, and the technique is called as what doping. So this is one main use. Second main use what whenever we go in a ship for long journey. So nowadays we use a highly sophisticated instruments, but till today the good old method is there. So throwing the what calcium phosphide or the calcium carbide containers in the sea. So when they are opened and thrown in the sea, they give a lot of smoke, dense smoke, thick smoke. So from that with reddish tinge, so that is the indication that uh, one particular boat is nearby. Okay, so using navigation we do nowadays, no doubt. Okay, but uh, anyway, it is giving good result. So still today we use this old method of giving signal that I am here in this area. Or during the war, okay, to control the mob. So for all these purposes, we create artificial smoke. Okay, suddenly we go for explosion of all these phosphides chemicals by the police, by the authority, by the military. That time a thick smoke is generated on the road or wherever they are protesting. So thereby the protestant they can't see properly what is happening. So time being they can police can control and they can bring some other what lathi everything. So the next level of control. Okay, first level warning, second level once again warning, third level screen, then again tear gas, then stepwise they go. Okay, so under extreme case, that too with the permission of a deputy commissioner DC. So they go for firing. Okay, firing is the last resort to control the mob. Hmm? So only DC has to give order, written permission. Okay, so all those are their controlling methods. So one controlling method is what using the screens. These screens are phosphorus screens we use. So this is the second use, and third is it has got a unwanted smell, no, that odor. So that's why it is used as a pesticide. I told in the beginning only, the first sentence. So that no pest will come, whether it is a for the household or in the field. So it is used as what pesticide. So these three are most important. Remaining, just have a glance. Now after the hydride of what phosphorus, now we'll go to the halides of phosphorus. So bromides, chlorides, iodides, fluorides, and the acetides of phosphorus. But we learn only about the chlorides of uh, phosphorus. And the two important chlorides are, one is the phosphorus trichloride PCl3, and the other one is what phosphorus pentachloride. So phosphorus trichloride PCl3 structure. So one lone pair of electron on P. So it is prepared by the direct combination of its constituent elements or by using the thionyl chloride. Okay. So only thing is we require a chlorinating agent. So chlorine supply, then we get a corresponding what PCl3. So very easy method. So I'm going. So regarding properties, colorless, low boiling liquid PCl3, it fumes in moist air. Okay. So PC, it keeps giving. It is highly reactive. Okay, that chlorine gas comes. That's why it is called fuming in moist air. And pungent odor. This pungent odor is exclusively because of what chlorine. So it is not due to the PCl3. It is giving. It keeps giving that chlorine gas. That's why it is pungent. So wherever PCl3 or PCl5 is stored, so we get a kind of chlorine smell. So that is called pungent smell. Regarding chemical properties, whenever it reacts with water, it converts into what its corresponding acid. Okay, so there are two important acids of phosphorus. One is phosphoric acid, other one is phosphorus acid, like sulfurous, sulfuric. In the same way, phosphoric and phosphorus. Phosphorus it is S3PO3. Phosphoric is S3PO4. So it is PO4 and PO3. So that changes in the structure part. So those to get those acids we use PCl3 in water. Okay, or PCl3 is one of the most important chemical as a chlorinating agent for most of the organic reactions to prepare chloride related compounds. Okay, whether it is a acetyl chloride or alkyl chloride, alkyl halide, aryl halide. So any halogenated compounds of organic chemistry, if you want, we use both PCl3 and the PCl5. So PCl3 and the PCl5 both are known as what? Chlorinating agents in organic chemistry. And shape is what? Pyramidal shape. Okay, already we know in the beginning. So it is used, as I said just now, as a agent, chlorinating agent in the organic chemistry. So all those use, there is only one use, important use. So structure part, diagonal, bipyramidal. So diagonal, pyramidal, not bi, only one is there. So the lone pair of electron on the p. So it is also given one particular sort of geometry in space. So it looks like tetrahedral, but not actually tetrahedral. Okay. So it looks like it is a distorted, disturbed tetrahedral, but the correct name is what? Trigonal pyramidal. If you join the three vertices of a triangle in space in 3D, you imagine the three chlorine atoms. So that becomes the triangular base. And after becoming the triangle base, on the top we have the lone pair of electron. And if you join all the three vertices of the triangle, chlorine triangle, the lone pair of electron, it looks like a pyramid. So therefore, for this reason, it is called as what? Diagonal pyramidal shape. Please recall chemical bonding chapter. Okay, right. Now phosphorus pentachloride. Phosphorus pentachloride. So pentachloride is still unstable than the PCl3. Okay, both are unstable, but this PCl3 is more unstable. Why? It is because of what? Once again, structure part. Okay, so out of the 5 Cl in PCl5, 3 are on the triangle, that is the base, and 2 are one above the triangle, one below the triangle. Okay, so the 2 chlorine atoms which are above and the below, they are called as what? Axial chlorine atoms, and the 3 atoms which are there in the triangle, they are called as the equatorial and the axial chlorine atoms. So it is the chlorine atoms which are on the above below the triangle, so they are unstable, bond length is more, you can rupture easily just by the heat. So PCl5 always keeps giving Cl2 and PCl3. It is unstable compared to PCl3. Okay, so this all is explained only on the structure part. And the same method what we have used in the case of PCl3, same method here also you can employ either by direct combination of the constituent elements or using the thionyl chloride. Okay, right. So regarding properties, so yellowish white due to the continuously giving the chlorine gas. Okay, that is the reason why it some small impurities present in the PCl5, that becomes slightly yellowish. Okay, crystalline. So all those are normal physical properties. Main is chemical properties. First important is water. It is highly unstable. Okay, so it gives PCl3 and the Cl2. Okay, so in the water, more amount of water or less amount of water, accordingly we get what corresponding products. So only thing is in less amount of water is the phosphorus oxychloride, whereas if you add a more amount of water, so a small pinch of a PCl5, full test of water, thoroughly boil, so you get what? Acid. Okay, so to get acid, add more water, and to get phosphorus oxychloride, limited amount of water, just let it dissolve only. Okay, so in that way you can prepare corresponding products. Excuse me. Again here these are reactions of what? These are the reactions of organic chemistry, where PCl5 is used as a supplier or agent of chlorine. So therefore this is called what? Chlorinating agent, already explained. So corresponding chlorides, alkalides, all those are formed here. Okay, right. Now you see, so in the solid state, this is the most important part of the PCl5. So in the solid state, PCl5 will exist as PCl6 and PCl4. That means PCl5 in the solid state exists as 2 PCl5 units. So those 2 PCl5, so 2 PCl5 means what? P2Cl10. So that P2Cl10 will exist in PCl6 and PCl4 units. Okay, so highly ionic. So because we have the positive and the negative charge on the PCl6 and the PCl4. Okay, and structure also I have given. So PCl6 is what? Octahedral, because 6 chlorine atoms are there, no? So 4 on the quadrilateral, one above the quadrilateral, one below the square of the quadrilateral. It gives the octahedral look, and PCl4 is a tetrahedral, because 4 chlorine around the phosphorus gives tetrahedral shape. So that means, so PCl5 in the solid state exists as PCl4 and the PCl6 combination. So plus part is PCl4, normally we write in the beginning, and the negative part we write at the end, PCl6 minus part. So it is together. Okay, as it goes to liquid state or the gaseous state, and the separation starts. But in the solid state, you will have two structures. They keep changing very frequently, so very difficult to isolate. Now, same chlorinating agent, it is used, and this is regarding what structure part. So, two triangle and one above, one below. This is called trigonal bipyramidal. Earlier it was trigonal pyramidal. Now one pyramid above, one pyramid below. So for this, you have to join the three chlorine atoms which are there on the triangle to the the first one, the above the triangle, below triangle. That looks like a pyramid type structure. So that's why it is called what, triangular bipyramidal. Once again, chemical bonding chapter. Okay, so I think today we discussed two important class of phosphorus, hydride and the halide. In the halide, again chloride. So in the hydride it is pH3, and in the chloride, in the halide it is chloride, and in the chloride it is PCl3 and PCl5. So important point is what about the pH3. Okay, smell and its use is important. And second is in the PCl5, PCl3 structure part is very important. Please practice structure. And PCl5 is highly unstable, keeps giving the two chlorine atoms, which are there on above and below. Okay, so then how PCl5 exists in solid state in the form of PCl4 and PCl6 tetra and the octahedral form. So preparation part is very easy, direct combination or thionyl. So use part is very easy. So only important part is what, their structure part. And in the case of phosphine, it is how the phosphine is purified. It is converted into phosphonium iodide with HI. Then once again it is made to react with KOH, so that a free pH3 is collected, uh, then excluding all those impurities. So these are the important areas of today's discussion. So still some few minutes time is there before it winds up automatically. So most welcome. Any doubts regarding the PCl5, PCl3 and the pH3?
Sir,
Huh. Yeah,
sir, does C2Cl10, sir, exist as dimer?
it's not dimer actually. Dimer is the what you have seen in the acetic acid. Okay, so same unit. So CH3COH,
Yes,
CH3COH, or in the case of BH3. Okay, so BH3, BH3,
yes, sir.
B2S. That they you can take those as a dimers. Okay, not this one. Okay, so this is different totally. So one is PCl6, one is PCl4, tetra and the octa. They both are
Yes,
BH3, BH3, both are CH3COH only. No different forms. Only hydrogen bonding. Some other interactions are there, but here totally different structures are there. So it is not taken as what, dimer. So it is together two units of PCl5 in the ionic form. Then
Sir,
uh,
pH3 is water soluble, sir.
slightly, not that much. It is more of covalent. Okay,
Yes.
so small amount of pH3 is soluble more in the organic solvent. Then
Then pH3 is non-polar, sir.
pH3,
Is non-polar.
pH3, what is non-polar? No poles.
No poles. Yes.
Poles are created. Poles are created here. NH, how?
Electronegativity is similar, no, sir. P and H.
Similar is there, but small difference is there. The difference is enough for the pH3. So to go for the electrical poles, and it is not that like a Cl or like
Yes, sir.
what where difference is more. Hmm?
NH3.
Uh-huh. So as the difference is less, so we have less covalent, more of ionic, or 51, 49. So in that way. Hmm? Next.
net dipole moment.
Correct. Exactly. The word is what? Net dipole moment. It is the structure, it is the electronegativity that matters. Ultimately, they go for the poles which are moving dipole moment. Next. Structure part already we learnt in the 11th class only. So it's a kind of revision. Only thing is you have to understand the preparation part, direct or the thionyl. Then uses a normal chlorinating and phosphine as a smoke, vagera, all those.
Users will not come in exam, sir.
Uses maybe for 1 mark in the beginning. Nowadays pattern is changed, pattern. So
Because
suppose
the, for all compounds, sir, they have given users in that
yeah,
yellow box.
yeah,
Sir.
correct. Because see, in chemistry, if you don't recall uses part now, there are two famous uses for every chemical. It is used as reagent. It is used in the industry. Khatam. So we can't say wrong also. You will get marks. Even if you don't understand,
But
when you're
this
not in
time,
a position to recall the exact uses, at least you write as a reagent in the normal laboratory or in the industry. That is the most common use we write. But please write the correct use. If not, when the time comes in emergency, time is not available when you are not in a position to recall that you can supply. Okay, so that will give marks. So it's not wrong. So uses part normally you will not ask. In chemistry, it is the property part and the structure part. Only these two. Then I think it is clear, almost all clear.
Sir,
So you
sir, what is meaning of vitriol, sir?
vitriol. What vitriol? Spelling?
Yes, sir.
Spelling.
VIT, blue
Ah,
vitriol देता है.
vitriol. So vitriol is the Greek or the old literature. It is a kind of solid. So the one which looks a blue color, it is called blue vitriol, green vitriol, yellow vitriol. Okay. So these words we use for the what? D block salts. So vitriol is you are allowed to use for the D block solids, depend upon the color. So blue vitriol is copper sulfate, green vitriol is the iron sulfate, and so on. So these two are the most famous vitriols we come across in the 11th and 12th. So vitriol, you take it in the sense what? Solid. Then
Just like
blue vitriol,
precipitate,
copper
sir.
sulfate.
how it occurs in the test tube, solid form. Yeah. Then
Sir,
uh,
blue vitriol is copper sulfate, sir, and one more, sir.
iron sulfate,
Yes,
ferrous, light
yes,
green.
Green.
Light green.
Fe2 plus.
That is green vitriol. Then, so soon I am going to give the marks list. Okay, don't worry. So you are done well. Keep doing well. So okay then, my dear students.
Sir, sample question paper, sir.
Of what?
They give total, sir.
Yeah,
Mark
yeah.
exam is of 35 marks.
About the number is yes, yes. The work is going on.
But in
So the moment we
sample question
download,
paper,
it will be floated in the group.
yes, sir.
So okay then, keep in touch, keep thinking. So thank you very much for your what being online soon after examination, after taking a small break. So we continue our academic journey. Okay. So thank you and all.
Thank you, sir.
Thank you very much.
Thank you, sir.
Thank you.